Now let's talk about how to add parallel lumped elements to your circuit. Here's an example where we have a capacitor, an inductor, or a resistor in parallel with a transmission line connected onto our load ZL. In this case, we're going to do the same steps. The first thing that we're going to do is normalize ZL and plot it on the Smith chart. Then we're going to rotate a distance L towards the generator. That's going to put us right over here, finding ZA as we did before. So we can find ZA, but we're not going to read it yet because ZA is not what we're going to be using. The next thing that we're going to do is we're going to transform ZA through the center of the Smith chart, through the chart center, to YA. So we're going to find the admittance, and this is still normalized, and we need to find the admittance in mhos. In order to find the admittance in mhos, we're going to denormalize, read and denormalize YA by multiplying it by Y naught, and that's going to give us mhos. Remember that Y naught is just 1 over Z naught. So that's going to give us a value YA, which is right here, same location as ZA. Then what we're going to do is calculate the admittance of the capacitor, or the admittance of the inductor, or the admittance of the resistor, and add that to our YA value. So YC is J omega C, and that's given in mhos. YL is 1 over J omega L, and that's given in mhos. And YR is 1 over R, which is also given in mhos. In order to find Yin, that is equal to YA plus YC, L, or R, and that will be a value given in mhos. So that allows us to calculate the input admittance right here at the center. If instead we want the input impedance, that's just 1 divided by the input admittance. Now let me ask you, what would happen if we had both a series element, such as resistor, and a parallel element, such as an inductor? How would we handle that? Well, this is how I would do it. I would start out with my load, normalize it, transform it through the length until I got to this point. I would add in ZR because that's in series. Then I would plot that on the Smith chart, and then I would rotate it through the center until I got to YA. Then I would calculate Z of the inductor, calculate Y of the inductor, and if I wanted to find Y input, that would be YA plus YL.